cosine, inverse tangent, inverse, all the inverse functions. Yes, sir. Oh, on the quadrangle?
Yeah.
Okay.
It was quadrangle, right?
I believe so.
Yeah.
What happens here, guys, is we're going to be asking the questions, just like we were saying a second ago, what angle has the sine of root 2 over 2? What angle has the secant of 2? Things like that, which means it's all based off of the two right triangles again. Everything that we have done, all the work that we've looked at, is all based off the two special right triangles. But now, when we do our inverses, there's going to be one stipulation for each of the three main inverses: cosine, sine, and tangent. The stipulations are as follows. When you have to find the inverse cosine of an angle, the inverse cosine of an angle, that degree measure or that radian measure, will always be between first and second quadrant. If you look at it, that helps you to figure out where cosine is both positive and where cosine is negative. Okay. When I take care of sine, I'm always looking for sine values that wind up being between first and fourth quadrant. Because it's negative there. Oh yeah, no. Because they're positive in first and negative in the fourth. Instead of, because if I go to first and second quadrant sine is still positive. Okay? And then when I go to tangent, come on guys. When I go to tangent, I'm also worried about first to fourth. One of the things that I want you to remember is that your tangent of 90 degrees, or your tangent of pi over 2, is undefined. Because it's y over 0. You can't divide by 0. Same thing here. So your tangent is always going to be between pi over 2 and negative pi over 2, not including less than or equal to. Because it can't equal pi over 2. This is an asymptote. Okay. That's the other reason why tangent jumps from quadrant 1 down to 4, because they're positive here, negative here. They're positive and negative in the second quadrant, but I can't have a continuous function to cross over 90 degrees because the 90-degree tangent doesn't exist. Yes, sir?
Why is it that
I'm looking for a continuous positive and negative change for each of those trig functions. Cosine starts positive in the first quadrant, it's continuous, and it goes to negative in the second. That's a continuous arc, if you will. Sine, if I went from first to second, it just all stays positive. It just repeats itself. I don't want that. That's why I'm saying from 90 degrees to negative 90 degrees, that's my sine value. Yeah, and same thing with the tangent. If tangent goes positive to negative in first and second quadrant, but tangent doesn't exist at pi over 2, that's why they make it bound going into first and fourth quadrant. When you see a couple of these examples, it's very, very easy. Okay? Let me show you one. If I want to talk about this inverse sine of root 3 over 2, by now, all of you guys know what triangle I'm working in with root 3 over 2. 30, 60, 90. Good. So what I'm doing here is I'm working in a 30, 60, 90 triangle.
So we're finding the degree.
Which angle has a sine of that? Thank you, sir. Which angle has a sine of root 3 over 2? 60. 60 degrees has the sine of 3 over 2. What is that in radians?
Pi over 3.
There's your answer. What is the angle that has the sine of root 3 over 2? 60 or pi over 3. Yes, sir.
So you don't have to worry about it'll always be in the right spot.
It'll always be, I'll show you when we'll have a negative angle here in a little bit. What'll happen here is that you will have negative angles. Instead of spinning around to say negative 300 degrees, you can just say negative 60 degrees. Because you're looking at being bounded between here and here. That's why they're saying your angle measures are between positive 90 and negative 90.
It'll never give you one outside of it though?
Not with this stuff, without a calculator. If you had a calculator, yes. But here it's always going to be something that's going to be bound within a reference angle that will occur within the fourth or the first quadrant. Yeah, Morgan?
So basically all you want us to do is draw a triangle and just.
It's the easiest way. It's the easiest way to do this. Okay. Show you another one. Cosine of 2. Now, when I'm thinking about cosine again, remember, cosine, it's bounded between first and second quadrant. What are the ordered pairs for cosine on the outside? With negative 1, 0 here, and what's this one? 1, 0. Can cosine ever equal 2? No. Okay. Tangent of negative 1. Yes, it won't. It's not under. It just doesn't exist. No, it doesn't exist. You can't have a cosine equal to 2. Think about what it looks like in a triangle. If you have a 2, that means which triangle you're working with. 30, 60, 90. So if I have a 30, a 60, and a 90, 1, root 3, and a 2. Now, the only way I can get 2 for an answer would be which trig function?
2 over 1 was like an inverse?
It's an inverse. Which one? Cosecant.
Oh,
Because sine is 1/2, cosecant would be 2 over 1. So you start playing around with where the things are positioned in the triangle. Now, if I'm at tangent of negative 1, we all should know which angle is going to wind up with tangents of 1. Remember which ones they were? It's the 45, 45, 90. Because in order to get tangent, it's y over x. Y over x can equal 1. That means both y and x are the same. The only triangle that has the same y and x value is the 45, 45. So if I'm looking at that, it's 1, 1, and root 2. So if I'm looking at which one of those gives me a tangent of inverse tangent of negative 1, well, tangent is defined within those 2 quadrants. Which one of those 2 quadrants is the negative for tangent? It's the quadrant 4, which means this would have to be at the reference angle of a negative pi over 4. This is a negative 45-degree angle, or negative pi over 4. When we're finding inverses, we're not spinning them around to get the obtuse, or I don't want to say obtuse, the positive angles here. We're able to use positive or negative angles for sines and tangents. And then with cosines, you're going to use acute to obtuse angles. Does that make sense? Sines and tangents, you can have negative angles. Cosines, you can have acute or obtuse. We need a couple more. Take a minute, try those. Again, tangent of root 3, which triangle is it?
60.
It's the 30, 60. The tangent, to get opposite over adjacent, has to be at 60 degrees, or?
Pi over 3.
Good. Cosine inverse of root 2 over 2, we all should know this one off the top of our head. Very good. Pi over 4, or? Good. Everybody got that one? Okay. Sine of 1/2. Again, we're using the 30, 60, 90 triangle. I'm just going to kind of just leave this one up. I bet sine of 1/2. Which one of the angles gives me 1/2 for that sine? 30, or? Good. The last one is the weird one.
That's pretty good. I like it.
When you're working with cosine and it's going to give you a negative value, that tells you which quadrant will you have to be in.
Top of the second.
You mean the second quadrant. Remember, cosine is bounded between quadrant 1 and 2 when we're doing the inverse values. For it to be negative, it has to be in quadrant 2. Now, when you're looking at that, to get a 1/2, again, you are a 30, 60, 90. 1, root 3, and 2. Which one of the trig functions has a cosine of 1/2? 60. Now, what's happening here is that you are getting the reference angle of 60 degrees, which means it's an obtuse angle that brings you over to it. What's the obtuse angle that has a sine, or is a cosine inverse of negative 1/2? Negative 1, or excuse me, positive 120. 120 degrees, or,
2 pi over.
very good.
Well, couldn't you also do it in third quadrant? You
No.
just wouldn't need to.
But yeah, because cosine is only, when you're doing inverses, cosine is only, you're only looking at it within the boundary of first and third, or excuse me, first and second.
Oh,
Because you want it to be continuous,
alright.
okay? And that's what we're looking at today. Next week, we get into this a little bit more. We'll talk about the weird stuff with calculators. Tonight, I guess 1 second, Lee. Tonight, I want you to do these 8. It's on 795, 18 through 25. Yes, Lee?
Oh, what we're doing?
For that last one,
Yeah.
What we did.
how did you get that again? I would have gotten like 1/5.
Wait.
When we were at,
What was the thing?
it was a 30, 60, and it was the cosine of negative 1/2. So we have to look at the cosine of 1/2. That's here.
The last one was sine, all right.
If you did it in class.
I
Yeah.
was looking at the one.
Oh, okay, yeah.
Alright.
All right.
No, don't
Lose it?
790.
It's on page 795,
Oh.
18 through 25.
Turn the
There's
light
8 of
Turn
them.
that up.
There's 8 of them. You're doing inverses. Please give me degree and give me radians. All right?
If we just did them, can we just write the answer?
That's fine.
We didn't just do it.